When we're working with collections, it's pretty common that we want to be able to add things to them or sort of concatenate them together to combine them. But there are situations where we want to combine them in a different way. Maybe where we want to zip them together. Hi, my name's Nick Cosentino, and I'm a Principal Software Engineering Manager at Microsoft. In this video, we're going to be talking about the LINQ zip method along with the MoreLINQ zip shortest and zip longest methods. We're going to go through the very basics here, and then I'm going to show you as well how we can go try to build our own, just so we can see what it looks like before we just start using the shortcut of LINQ. If you stay right to the end of this video, we'll be diving into the benchmarks for comparing all of these different approaches. A quick reminder that if you find this kind of content useful, remember to subscribe to the channel and check out that pinned comment for my courses on DomeTrain. With that said, let's jump over to Visual Studio and start working with some collections. On my screen here, I have two collections, Source 1 and Source 2. I will briefly talk about some of these enumerable methods that we have going on here, but if you're not familiar with IEnumerable, iterators, and things like that, I do have plenty of videos available on my YouTube channel. You can just search for enumerable, IEnumerable collections, and you'll see a whole bunch of really basic tutorials. The first collection that we're going to have up here is going to be from 1 to 5, and then I'm going to have a second collection that goes from the numbers 1 to 10. But what I'm also doing here is I'm reversing it. I am going to be dealing with some strings here, so I'm just converting these numbers into their string representation, and that'll make a little bit more sense as we go ahead with some of these examples. The other thing you'll notice is that I am making these enumerables into full-on arrays, so I am materializing these enumerables into collections. Okay, when we're talking about being able to zip things together, the idea that we want to do is instead of putting one collection followed by the other, we want to be able to combine the collections into something new. And that means that for each one of these items that we have in a collection, we sort of want to take the first one from the first collection and the first one from the second collection and make them into something new. And then we would go on to the second one from the first collection and the second one from the second collection and put them together. Instead of having one for loop for the first one and one for loop for the second one to combine them and step through them, we actually want to be able to step through them at the same time. That's conceptually what we're trying to achieve here. The other thing that you'll notice is that I purposefully made these different lengths, right? So one is 5 items, the other one is 10 items. And this is because this is an interesting constraint or edge case that we have to think about, and that is if we're trying to combine these collections and they are of different lengths, what would the expected behavior be? Before we continue on, this is just a quick reminder that I do have courses available on DomeTrain. If you're just getting started in your programming journey and you want to learn C#, you can head over to DomeTrain. I have a Getting Started in C# course. It's approximately 5 hours of content taking you from absolutely no experience to being able to program in C#. And after that, I have my deep dive course, which will take you to the next level with another 6 hours of content so that you can start building basic applications. Head over to DomeTrain and check it out. Let's head back to the video. When we go look at the LINQ implementation versus the MoreLINQ implementation, LINQ will basically take the shortest of the two. So if you had 1 to 5 and 1 to 10, the resulting collection will only be 5 items. However, with MoreLINQ, we get zip shortest and zip longest. And that means that we have the option to pick between the behavior that we want. But I want to start off by doing a bit of a naive implementation just to kind of show you how we might go approach this, right? So if we know that we have 2 collections here and we have 2 different lengths, probably what we want to consider is that we're going to take the minimum between the 2 of these, and then we can start stepping through them. So to start things off, we would do something like a count where we take the minimum of the 2 different collection sizes. So source length 1 and source 2 length here right after. So now, once we execute line 13 through 15 here, we have the shortest length. From there, it's going to be relatively simple. We're going to step through both of these at the same time with a for loop. So we would do for int I equals 0, I being less than the count, and then increment I. And then from there, we'd be able to grab each item at the index from each different collection. But we haven't yet talked about what the resulting item is supposed to be. So we have, in this case, a string and a string. What should we be doing with them? And when we're dealing with the zip function, so this extension method that we get from LINQ and MoreLINQ as well, you're able to pass in your own selector, and that will give you the option to take the first element and the second element and decide how you want to combine them. In my case, I'm just going to make a tuple or a tuple, depending on how you'd like to say it, and then we're going to add that into a list. So I'm going to put that list up here. So string, so this is going to give us a tuple. This list called results has an item type that is a tuple or a tuple of string and string, and then I'm going to basically add into the results. We'll see if Copilot can do it right away for us. It kind of did. There we go. So Copilot, thank you. So we're going to make a new tuple in here. We're going to take the first source and we're going to take the item at position I. We're going to take the second source and take the item at position I as well. Now, at the end of running this for loop, we will have a collection that is populated with the results all the way up to the shortest of the two. So in this case, it's 5. So we won't even do from 6 to 10 in the second collection. But there's something that's different about this approach that we just kind of walk through, right? This is a very naive, sort of almost like pseudocode approach to how we might go do zip. But the big difference is that I had to go make a materialized collection, right? So I created this collection ahead of time, and then I started adding in the elements. When we're dealing with things like LINQ, we are not creating a new collection unless we materialize it. So if you write toArray, toList, kind of like I have here on line 11 and line 6, when we're working with LINQ, these are still just IEnumerables. And it has this sort of pipelining effect or this streaming approach. Whereas with this example, what I have done is I created a whole other collection ahead of time. So that is a very big difference. Again, if you're not familiar with iterators, please do a search on my channel. I do have videos explaining yield return, iterators, and IEnumerable. So this is one big fundamental difference, but this should demonstrate the concept of what zipping is attempting to do. With this example, we were also working with a little bit of extra information that when we're in LINQ, we're not necessarily having the luxury of working with, and that is the collection being materialized. So in both of these collections that we had, they were full-on arrays. That means that we can index into them, and it also means that we have the length of them. When we're dealing with IEnumerables in LINQ, we don't have that luxury. If we have an IEnumerable, we don't know the count. We also don't have the ability to index into an arbitrary point into an IEnumerable. So while this was a bit of a naive approach, it also meant that we were able to take advantage of some extra things that LINQ is not able to rely on strictly when dealing with IEnumerables. Jumping down to the bottom of this file, I already created an extension method that deals purely with IEnumerables. And again, this is just to demonstrate a very naive approach for how we can step through 2 IEnumerables at the same time. So if you're not familiar with extension methods or you're not familiar with IEnumerables and generic types, this might look a little bit confusing because you'll see a lot of like T1, T2, T result. Like this is a selector function that has 3 type parameters. This might look pretty confusing, but I'll explain what's going on here. Kind of like the method that we saw that we just created, we're going to be dealing with 2 IEnumerables, and you can see that I have source 1 and source 2. The this keyword just allows us to create an extension method, so that means when we go to call this, it will look like we're able to say manual zip shortest after the name of one of the collections. So it would look like source1 dot manual zip collection. Then we're able to pass in source2, and then we can pass in a selector function. Source2 is just going to be some other IEnumerable in this case. Again, we're dealing with IEnumerable for this example and not arrays or lists, so they're not necessarily materialized collections. This func here called selector, the way that this works is it's going to take in one element that is of type 1 and another element that is of type 2, and it must return a type of T result. In our example that we made before this, we were taking basically a string for T1, a string for T2, and then we had a tuple of 2 strings as the return type. So hopefully that explains what this syntax looks like, although I do admit that it's a little bit gnarly if you're not familiar with type parameters. The next part that we're going to look at is a very different way that we're looping through these 2 things. And if you recall, I mentioned that we got to cheat a little bit earlier when we were dealing with arrays, and that's because we knew the length and we could index into the array. We simply can't do that if we're dealing with IEnumerables. We don't know if it's backed by an array or backed by a list, or if it's truly just some connection to a database or connection to some web service. We don't know that, and we can't tell unless we were to dive into the code. So we need to basically assume that we can't do that. IEnumerable allows us to access an enumerator. So you'll see on line 93 and 94, if I highlight both of them here, we're getting an enumerator for each of these. You'll notice that both of these on line 93 and 94 also have a using statement out the front, and that's because they are idisposable. So we need to make sure that we're cleaning up after ourselves in general with anything in C# that's marked as idisposable. Now, the while loop that we have here is different than the for loop that we had, but it's achieving the same purpose. In the first example, we knew the count and we said, hey, look, let's just loop until we reach that count. In this case, all that we're saying is loop as long as we're not at the end of one of these two IEnumerables. We don't need to know the count ahead of time to find the minimum between the two. We can simply just keep trying to walk forward, and as soon as both of them are not able to walk forward, then we're able to stop the iteration. You'll notice that I did mark this as manual zip shortest, and the example that we made in the very beginning of this was also an implementation that did the shortest. It might be a little bit easier to see here, but you notice this and symbol. So we're saying walk through both of these while we can move next in one and we can move next in the other. If we wanted to do manual zip longest, we would be able to do something like this and essentially say as long as we can move forward in one or the other. Now, it's going to be a little bit more complicated to do a zip longest because when we go to ask for the current, essentially we need to have a default value that we're zipping alongside. So we aren't going to do that for now, but I just wanted to highlight that this is one spot in particular, line 95, that you might want to consider if you were doing zip longest instead. Now, if we go to look at line 97 through 100 here, we are going to be calling our selector callback, and we're passing in the current item from the first collection and the current item from the second collection. The result of executing this selector is going to be however we decide to combine these two things. And you'll notice that I do have a yield return here. So yield return combined with an IEnumerable gives us what's called an iterator. And this is another part that's very different than the method we made at the beginning of this video, because in this case, we are yield returning and not making a whole collection ahead of time. So this truly acts like a pipeline yielding one thing back at a time, whereas the first example made an entire collection before we could even start to go work with it. So that's going to be one of the fundamental differences. I recognize that if you're not familiar with iterators, yield return, this kind of stuff is a little bit weird, but I do recommend you play around with it. And like I said, there's other videos on my channel that you can check out to understand this in more depth. Okay, so we were able to go build a naive implementation up here. I'm going to comment this out, and we are able to go ahead and use our other approach that has an extension method. But it's about time that we go look at the built-in stuff that we have. So I'm going to go introduce the LINQ variation and the MoreLINQ variation as well. Okay, so the example program that we will be running is going to start off with the built-in LINQ zip method. And all of these examples are going to have a very similar syntax. So you'll see source 1 zipping with source 2. And this syntax, again, I admit this looks a little bit nasty if you're not familiar with anonymous delegates, but this is essentially going to be the item from collection 1 and the item from collection 2, and kind of think about that we're stepping through that for loop, and each time that we're stepping through that for loop, we're going to have an item 1 and item 2. And the right-hand side of this arrow is just how we're going to combine them. So this is going to make a tuple that has X and Y. So in this case, the string from the first one and the string from the second one combined into a tuple. Arguably, this syntax looks kind of ridiculous because it looks like we have the same thing on the left and the right-hand side of this anonymous delegate. We're also going to be putting that into an array, and then we're going to write this information out to the console. The next two methods are zip shortest and zip longest, so right here, and these come from MoreLINQ. You'll notice that the way that we call these things is literally the exact same except for the method names, and we're just going to print this information out to the console as well. All of these will be combining the two collections by making a tuple of string and string. Finally, the manual zip shortest, which is the extension method that I had walked you through, this also has the exact same calling style. The difference is going to be the name and the method that we're calling. Manual zip shortest should behave, in theory, just like zip shortest, which should behave, in theory, just like the zip method that is built in. Zip longest is going to be the outlier here, and that's because it will try to take the longest of the two collections and it will backfill the empty spots with a default value. So hopefully that makes sense. And what we're going to do now is run these and look through the results. Starting things off with the zip method that is built into LINQ in C#, we can see that we have the numbers 1 through 5 and then 10 through 6 on the other side. And I did purposefully reverse these so we could see differences in the numbers. That way you wouldn't see 1 beside 1 all the way through and be confused that maybe I just passed in the same collection. Truly, it's working backwards in the second collection. So when we zip them together, this is going to be the first element of the first collection and the first element of the second collection, and then so on and so forth. So one will be counting up, one counts down as we go through. But you'll notice because the shortest collection had 5 elements, we only get up to 5. If we go to zip longest, and this is going to be from MoreLINQ, it's the first MoreLINQ method that we're looking at in this video for the output, you'll notice that we do the same thing, but once we hit 6, technically, that would be here, we don't have 6 in this first collection. So it will put in the default value, and the default value of a string is null. So it's printing out null here, and then you'll notice that we keep going all the way through until we iterate through the second collection, which is longer. It had 10 elements in it. So we get the numbers 10 through 1 printed out on the right-hand side, and the left-hand side only goes up to 5. If we look at the final 2 examples, these behave the exact same as we saw with the built-in LINQ zip method. Just a quick recap, the way that we're able to sort of combine 2 collections, or in this case, IEnumerables together, by zipping them is calling MoreLINQ zip shortest or zip longest if you want to be using MoreLINQ, or we just have the built-in zip method. I did also illustrate how we can go make our own, and a naive implementation that wasn't necessarily streaming these things together, but making a whole collection ahead of time. Now, I did mention that if you stayed at the end of this video, we could check out some benchmarks, so when that video is ready, you can check it out right here. Thanks, and I'll see you next time.